Hi, you guys. I'm going to do a quick Unit 5 with you guys, and I want to review a few equations. I want to go over like how to balance equations and kind of really like review some of the things that we've been learning, so that you guys are better prepared and you guys are able to like do your study guide and all of that. We're going to start off with this problem right here. So I'm going to just go ahead and I'm going to write this in. So I have CH4, my bad, CH4O plus O2, and I make CO2 plus H2O, right? So when I'm doing this, what I'm going to do is I'm going to list out all of my elements. So I have C, I have H, and I have O. So on this side, I have 3 O's. On this side, I have 2 H's and 1 carbon. I have 1 carbon on this side, 4 hydrogens on this side, and 2 oxygens on this side. So you'll see right off the bat, I do have a lot to balance, right? I'm going to start off simply. I'm going to start off with my hydrogens. So when I go ahead and when I start off with my hydrogens, what I'm going to do is that I see that I have 4 here. So I'm going to go ahead, I'm going to put a 2 right in front. And when I go ahead and when I put that 2 right in front, this is going to change to a 4, right? And my amount of oxygens is also going to change. So I have 2 here, 3, 4. So now I have 4 oxygens. And so I can change this to a 2. And you'll see right off of the bat that that is all, should be all balanced out. And we are set to go ahead and to actually solve a problem from there. So for our first problem, what we're going to do is that we're going to go ahead and we're going to look at if we had in a lab, we have 15 grams of CH4O, right? And we have, let's say 20 grams of O2. And we're asking how much water will be produced. Right, so that is a question that we're going ahead and that we're being asked. So we're going to go and we're going to use our balanced equation to answer that. So we're going to start off with our 15 grams of CH4O. Right, and they're asking for water. So we have to go from 15 grams of CH4O to grams of H2O. So that's what they're essentially asking us in this problem, right? Because they're asking us how much H2O. So I start off with 15 grams of CH4O, and then I'm going to go ahead and I'm going to convert that from grams to moles, right? So I'm going to have some sort of grams here, and I'm going to have 1 mole of CH4O. The next thing that I'm going to do is that I'm going to look up these weights on the periodic table. So carbon weighs 12. Hydrogen, I have 4 of them, so that's going to weigh 4. And then that's going to be 16, so I should have 20 plus 12, right? So I should have 32 grams, right, is CH4O. Right, so that is what I should have on there. Then the next step that I'm going to do is I'm going to use the mole ratio, so I can go ahead and I can flip, right, my CH4O to H2O, right? So I'm going to should have mole of CH4O right here, and then I should have mole of H2O up here. I'm going to go ahead and I'm going to look at my balanced equation, and the number that I have in front of H2O is 2. So I'm going to go ahead, I'm going to put that there. And the number I have in front of CH4, I don't have a number, so it's going to be a 1. Then I'm going to have to go ahead, I'm going to have to look at this, and 1 mole of H2O is how many grams? So I go ahead and I add those things up. So each one of these weighs 16, that weighs 2, so 18 grams of H2O, right? Now I can go ahead and I can multiply these things across. Oopsies. So I'm going to go 15 gram, no. Hold up. Let me go ahead and let me cancel my units so that I know that I'm on the right track. Okay, everything cancels, so I'm good. All right, so 15 times 1 times 2 times 18, right, would be what I get on the top. And then I get 32 times 1 times 1. And I would go ahead and I will multiply these things. So that'll be 30 times 18, which should be 540 grams of H2O over 32. So my total should be 16.875 grams of H2O. So that's how much would be produced if I had 15 grams of CH4 and unlimited amount of oxygen. But since I don't have an unlimited amount of oxygen, I only have 20 grams of oxygen, I'm going to have to go through this same process, right? So I'm going to go ahead, I'm going to have 20 grams of O2, right? And then for my grams of O2, I'm going to go ahead and I'm going to first go ahead and write 1 mole of O2. And then I should have 32 grams of O2 at the bottom. Then I'm going to go through my mole ratio. So I should have moles of O2 here. And I should have a mole of H2O here. So I know that I have a 2 in front of my H2O. And I'm going to look back up and see. And I have a 2 in front of my O2. So I'm going to go ahead and I'm going to put those things there. And then I'm going to go ahead and say 1 mole of H2O is 18 grams of H2O. And again, I got this 18 grams from the periodic table. I got these two numbers, right, from my equation, right? And then I got this number, again, from the weight of oxygen. So now I'm going to go ahead, I'm going to multiply these things out. So 20 times 1 times 2, skipped 1, times 1 times 2 times 18, right, over 32 times 2 times 1, right, and this will be grams of H2O, and this will be 1 mole. Oh, no, that does not have a unit. Just kidding. And then I'm going to go ahead, I'm going to multiply those things. So I should have 40 times 18, which is 720. And then I should have 32 times 2, which is 64. Divide those deals, 720 divided by 64. And I would have 11.25 grams of H2O, right? If they go ahead and if they ask, what is the limiting reagent? Right, so what if they ask, what is a limiting reagent? Then we go ahead and we're able to go ahead and compare these two answers. So I'm going to look at my two answers that I got, right? So 15 grams of CH4O, right? Yeah, CH4O, right, makes 16.875 grams of H2O, and 20 grams of O2 makes 11.25 grams of H2O. So I go ahead and I compare and I contrast those two answers with each other. So when I go ahead and when I compare them, what I'm going to do is I look for the one that is lower. So this one right here is lower. So since it is lower, this one is my limiting reagent.